In this video here, we're going to take a look at inclined planes. So when we're dealing with problems involving inclined planes, it is often just easier to resolve parallel and perpendicular to the plane. And it is also strongly recommended here to draw a force diagram to help visualize the problem. You don't have to, you wouldn't be penalized if you don't draw a force diagram, but I do think it helps massively to draw a force diagram for problems involving inclined planes. So the best way to demonstrate this concept here is to take a look at some examples. So in terms of an introduction here to inclined planes, we can't really go over too much more, right? There isn't really much to go over in terms of inclined planes. Like I said, the best thing to do here is to just draw a force diagram. So as we've said then, the best way to demonstrate this is to take a look at some examples. So let's get started then with question 1 here. So let's just get started here then with question 1. Now for question 1, what we have here is a particle of mass 1 kilogram, which is held at rest on a smooth slope that is inclined at an angle alpha to the horizontal. We're then told that the particle is then released, and we're also given that tan alpha is equal to 0.75. So before we move on here, I'm just going to rewrite this as a fraction. So tan alpha is equal to 3/4. Okay. Just makes life a little bit easier here. So for part A then, it just asks us to find the normal reaction between the particle and the slope. So straight away, what I can see for this question here, and hopefully that's quite obvious, right? We don't have a diagram. So what I need here is my own diagram. You don't have to, but I do find these questions very, very tricky without a diagram. So I would always recommend drawing a quick diagram if we don't have a diagram given in the question. So we've got the horizontal here, right? So that's the horizontal. We have a smooth slope, like so, and we have the angle of inclination. So the angle of inclination here is alpha. So that's alpha there. And what I'm also going to quickly do here, and let me just do this to the side here, I'm going to draw a right angle triangle. Okay. So why am I drawing a right angle triangle here? Well, because we know this angle of inclination here is alpha, and we're also given that tan alpha is equal to 0.75. So by using some basic trigonometry here then, if tan alpha is equal to 3/4, that means the opposite side here is 3 units, the adjacent side is 4 units, and then by using Pythagoras here, right, the hypotenuse must be 5 units. Okay, so in that case then, we can see that sine alpha, again just using basic trigonometry here, is equal to 3/5 or 3/5. And then for cos alpha here, this will be equal to 4/5. Okay. So now let's just go back to our diagram here. So I haven't quite finished my diagram, right? Because I didn't add on the particle here. So let's say that this here then is my particle. So my diagram is not going to be great here because I'm going to start going into the text here of the question, but it doesn't matter too much. So this would be the diagram representing this problem here, right? But we do also need the forces. So we need a force diagram. So we've got the mass here of 1 kilogram. So if I add that onto my diagram here as a force, like so, that will be G here. Okay. We also have a normal reaction between the particle and the slope as asked for in part A. That comes out of the particle here like so. And I'm going to label that as R. Okay, so it's getting a little bit messy here. Let me just write that underneath. So that is R there, the normal reaction between the particle and the slope. We've got G here, and we also have acceleration. So let's take acceleration as going down the plane here, like so. That's going to be A here for the acceleration, meters per second squared, like so. And then the only thing left to do here is split this force now into components here. Okay, so extend the line of action here with this force, like so. And then we get this here. Okay, so I've got this component here, and I also have this component here. Now, I do appreciate that my diagram is quite small, so it's a little bit tricky to see. So let me just do a bigger triangle here, right? I've got my force here of G, or G newtons. We then have our component here, like so, and same again here. Okay, and this forms a right angle triangle here. So I've got this angle here. Now this angle here is the exact same as this angle here. So this angle then is alpha as well. Okay. So in that case then, hopefully what you can see here is by using basic trigonometry, right, this component will be g cos alpha. So for that component then that is g cos alpha, like so. And then for this component here, so it's going to go in this direction and then that direction. So this component here, this will be g sine alpha. Okay. So g sine alpha there. So for part A then, so we've got everything that we need here now to answer part A and part B. So for part A then, we just want to find the normal reaction between the particle and the slope here. So for part A then, to find the normal reaction between the particle and the slope here, we're just looking to find the value of r here, right? Don't forget that r is simply the normal reaction between the particle and the slope here. So to find the value of r then, we're just going to resolve perpendicular to the plane here. Okay, so resolving perpendicular to the plane here, taking upwards as positive. So in that case then, what forces are acting upwards here, perpendicular to the plane? In this case, it's just the one force of r here. So we get r there, and we now consider what forces are acting downwards, perpendicular to the plane here. And as we can see then, that would just be this component here, which as we've labeled here is g cos of alpha. And because that's acting in the opposite direction here as to what we've took as positive, this will be negative. Okay, so we get r minus g cos of alpha. Okay, and this here then is equal to 0. And we're now going to solve for r here, right? Don't forget that r is simply the normal reaction between the particle and the slope here. So in that case then, nice and straightforward here, r is equal to g cos of alpha. So g cos of alpha. And don't forget then that cos alpha is equal to 4/5 here. So we get 4/5 of g. So that's 4/5 times by 9.8. Just put that into your calculator here. And what we get then is 7.84 newtons here. Okay. And there we have it. So that gives us the solution to part A there. Hopefully nice and straightforward. So now for part B then, it asks us to calculate the acceleration of the particle. So we're now going to take into consideration the acceleration of the particle. So if we're looking to find the acceleration here of the particle, we now need to resolve parallel to the plane, right? I'm going to resolve parallel to the plane here, and let's take down the plane as positive, like so. And we also need to use here Newton's second law. So we're also going to use Newton's second law of F equals ma here. Okay. So resolving down the plane here then, well, resolving parallel to the plane here, taking downwards as positive. What do we get here then? Well, going down the plane here, we just have this component, right? That would be this component here of g sine of alpha. We get g sine of alpha here. There's no forces going up the plane here that are parallel to the plane. That would just simply be our F here. And this is equal then to ma, which would be 1 times by a, which is simply a. So we're pretty much there now. So a is equal to g sine alpha. So in that case, then a is equal to g, which is 9.8, times by sine alpha, which is 3/5. So let me just rewrite that. I get 3/5 of g, like so. That's 3/5 times by 9.8 here. Again, just put this into your calculator. And if you do this correctly, then what you should get here is 5.88 here. Okay. And this is acceleration here. So don't forget your units of meters per second squared there. Okay. And there we have it. So that gives the solution to part B and the solution to question 1. And if we just say, look then at one more question here, we have question 2. So for question 2, then we have a force of 20 newtons that is pulling a particle of mass 4 kilograms up a smooth plane that is inclined at 20 degrees to the horizontal. We're given that the force acts parallel to the plane, and we then want to find two different things here. So for the first part then, we want to find the normal reaction between the particle and the plane. So for this question here, as we can see, right, we don't have a diagram to hand. So in that case, we're going to start here by drawing our own diagram. We'll do that up here, like so. But it doesn't have to be perfect, right? So as you can see then, this should be my horizontal here, and clearly that should be a straight line, but it doesn't matter too much, just so we can kind of visualize the problem. So we then have a smooth plane, like so, that is inclined at 20 degrees to the horizontal here. Okay, like so. And we have a particle of mass 4 kilograms. So I've got my particle here, like so. And this would be the diagram here, right, for this problem. But to find the normal reaction and to find the acceleration of the particle, we're going to need the forces added onto the diagram, right, as this little diagram here demonstrates. So in that case then, let's start with the mass here. The particle has a mass of 4 kilograms. That would be 4g here, acting vertically downwards, like so. So that's 4g there. We'll also have a normal reaction between the particle and the plane, as mentioned in part A then. That would be like so. Okay, so we'll label that as R here for the normal reaction. What else do we have here? Well, we also have a force of 20 newtons that is pulling the particle up the plane, right? So that's going to act up the plane here, like so. Okay, so that's 20 newtons there. So what I also need to do here is take this force and split that into components. So that would look, say, something like this here. Okay, so we get a right angle triangle. Now, this diagram here is pretty small for this, this triangle here. So let me just do this a little bit bigger to the right-hand side. So that would be forward G here. So forward G. And I've now got my components here. So we've got this component here going down. That would be perpendicular to the plane. And we've got this component here that is parallel to the plane. Okay, and altogether, this forms a right angle triangle. Now this angle here, this is the same as this angle here. That would be 20 degrees here. And now by using basic trigonometry, right, and just splitting this into components, what I can see then is this component here. So that's this component here. That must be 4g cos of 20 degrees. So 4g cos of 20 degrees. And then for this component here, that will be 4g sine of 20 degrees. Okay, like so. So we now have everything that we need here. That is our force diagram. Let's have a look now at answering part A and B. So part A then wants us to find the normal reaction between the particle and the plane here. So we're looking to find the value of R, right? That's just the normal reaction between the particle and the plane here. So for part A then, nice and straightforward here. All we're going to do is resolve perpendicular to the plane here, right? If we want the value of R. So as we've just said then, resolve perpendicular to the plane here. I'm going to take up as positive. So upwards is positive here. So in that case then, going up, that would simply be this force of R here. There's no more forces acting upwards that are perpendicular to the plane. We simply get R going upwards. And now we consider what forces are acting downwards perpendicular to the plane here, which in this case would simply be this component of 4g cos of 20 degrees here. And because that's acting in the opposite direction to what we took as positive, this will be negative here. So we get R minus forward g cos of 20 degrees here. Like so. There's no more forces acting downwards then, so in this case here, this is all equal to 0. And because all we're looking to do here is find the normal reaction between the particle and the plane then, we just want to solve for R. So in that case then, add 4g cos of 20 degrees to both sides. In that case then, R is equal to forward g cos of 20 degrees. Just put this here into your calculator. And if we give our answer to, say, 3 significant figures here, what I get then is 36.8 newtons here. Okay. And there we have it. So that gives us the solution to part A. So now for part B then, we want to find the acceleration of the particle. So for part A then, for part B, where we're looking to find the acceleration of the particle, we now need to consider the acceleration here. So given that the particle is being pulled up the smooth plane here with this force, and we'll take acceleration as going up here, like so, and we'll label that as a meters per second squared here. Okay, so to find acceleration here, what we need to do is use Newton's second law, so F equals ma here. I'm also going to resolve parallel to the plane. Okay, so I'm going to resolve parallel to the plane here, taken up as positive, and we're also going to use Newton's second law of F equals ma here. Okay, so what forces are going up the plane here that are parallel to the plane? Well, that would simply be this force here of 20 newtons, so I'm going to get 20. There's no more forces going up the plane here, so that's fine, so I simply get 20 there. Now what forces are going down the plane here? Well, we've just got the one force here then of 4g sine of 20 degrees. That's this component here, right? And because that's going down the plane here, we take that as negative, so I get 20 minus 4g sine of 20 degrees. Okay, like so here. So this here then is F. So this here now is equal to ma. So that's going to be 4 times by the acceleration of a here. I get 4a then, like so. So in that case then, all you need to do here is put this left-hand side into your calculator. So 20 minus 4 times 9.8. Don't forget we're taking g as 9.8 here. Just note that above. 9.8 meters per second squared here. So 4 times 9.8 sine of 20 degrees. Put that into your calculator here. So in that case then, and don't forget to divide it by 4, right? We just want a. If you do all of that correctly here, what you should find for a here is we get 1.65 meters per second squared there. Okay, meters per second. And there we have it. So that gives us the solution to part B, and that gives us the solution to the very last question. Losing my voice here. We'll try again. That gives us the solution to the very last question, question 2. That brings us to the end then of this video here on inclined planes.